in 5 minutes. We'll finish that in 5 minutes. Okay, so first of all, x, like no problem with x is normally distributed with that. Y is normally distributed with 103 squared. And then the total mass is W. Let's say M, like it just looks beautiful. Well, it's okay, you don't need to change yours. Okay, total mass is x1 plus x2 plus x3 plus ... until x20. But each individual of them will follow a normal distribution with mean 50 and standard deviation 4. And then plus y. This is not equivalent to 20x plus y. Okay, the difference between them is this one means x1, x2, until x20, they can take different values. They are different variables. They are different particles, like they are all separate and independent between each other. There's no connections between each other at all. But you have 20x plus y, which means you weigh one biscuit for the first one, and you use that result for all the other 20 biscuits. Does that make sense? Like, that's 20 times of the first one. This basically means that 20x of one weight. It's not true. Okay, each individual biscuit will have different values. So what we will have here is, well, let's see the difference. Okay, let's leave this. Let's leave this here. Let's have a look. What's expected M? Okay, expected M is expected x1 plus x2 plus ... plus x20 plus y. What that equals to? That equals to expected x1 plus expected x2 plus ... plus expected x20 plus expected y. Okay, and then because each individual of them expect value are the same, because they all follow the same distribution, then that is a 50, that is a 50, plus ... and that is a 50, and expected y is 100, like that. So how many 50s are there? There's 20 50s here. So the mean is 1100, right? Well, even though you have the same result as 20x plus y, but like it's totally different meaning. Okay, it's totally different meaning. And then your variance, the variance will be very different from that one. Okay, the variance will be very different from that one. So the variance of M is the variance of x1 plus x2 plus ... plus x20 plus y. Because they're all independent between each other, there's variance x1 plus variance of x2 plus ... plus variance of x20 and plus variance of y. Alright. And what's variance of x1? Variance of x is 16. Okay, variance of x, the standard deviation is 4, so the variance is 16. So you have 16 plus 16 plus 16 plus ... plus 16, and variance of y is 9. So how many 16 are there? There's 20 16s here. Okay, there's 20 16s here. That's 3 to 9. Okay, the variance is 3 to 9. And can you see what we did, like if we use that one? If we use that one, if that's a variance of 20x plus y, that's variance of 20x plus variance of y. That will become 400 variance of x plus y. But we actually should have only 20. Okay, we squared it, which is not correct. Yes? Okay, so that's the difference between. So it's definitely not that one. Okay, that's definitely wrong. So it can't have 20x plus y. It must be individual x1, x2, x3. Well, never write nx plus nby, something like that, unless the question gives that to you. For example, here. The question asks you what's variance of 6y. You are not create a variable like 6y by yourself. Okay, you are not creating 6y by yourself. Or if the question said, whatever result you have, you times that by 6, and that's variance of 6y. Okay, otherwise it's not. If it's like selecting different things that must be y1, y2, y3, y4 until yn. Okay. So now what we will have is M is normally distributed. Okay, because X is normally distributed, Y is normally distributed. So you plus all of that, it's still normally distributed. That's what we learned for this exercise, right? Linear combinations of independent random variables. That normal plus normal is still normal. So M is still normally distributed, with mean is 1, 1, 0, 0, and standard deviation, well, it should have variance here. So variance is 3 to 9 here. So A is asking the probability that M is greater than 1074. Okay, M is greater than 1074. So you have menu 5, 5, 2, 1074 greater than infinity, and the mu is 1100, and standard deviation is square root 3 to 9. Oh, okay. 3 to 9. Half bracket. It's this value 0.9241. Let's go for decimals. 9241. Okay, next one. Less than that. So probability M is less than 1120. So same distribution. What you have is negative infinity. You have 1120 and mean standard deviation 0.8649. 8649. And for C, lies between 1074 grams and 1120 grams. So probability 1074 1120. Okay, you actually could use 0. Okay, you have 1074, you have 1120. Well, greater than that 09241, less than that you want to find the thing in the middle. So you can add them and subtract by 1, but it's just too hard to do that. I can directly put that into the calculator. So 1074 1120 okay, 0.7890. Okay, that's this example here. After we find the distribution of the total mass, then everything is just by calculator. We just need to recognize the total mass. Okay.